Okay, so now we are recording. The slides and the recording of this presentation will be shared with you within the next few days. And so for attendance and
Uh-oh, we can't hear you.
I think we lost your audio, Clay. No.
how about now?
Yep.
Oh,
Yes.
terrific.
You're back.
Sorry about that, guys. The last couple admin reminders is just for attendance. Make sure that I can see your name. So if you've joined over the phone, or maybe you're sharing screens with someone nearby to you and you haven't actually logged into Zoom, make sure that you send me an email just to confirm that you are attending today. This is to make sure everyone gets their AIA and ZNCD learning units. I'll add my email address to the chat, and it will also be on a later slide in the presentation. So just make sure you send me an email if you've logged on today, but I can't either see your name because you're joining over the phone, or if you're sharing a screen with someone else. Another reminder is that the AIA learning units and ZNCD certificates were already distributed for part 1 of this series. So if you attended part 1 and you haven't received those yet, and you think that might have been a mistake, just send me an email and I can look into it for you. Okay. And so I know many of you have already tuned in for part 1 of this training, but for anyone joining us for the first time today, we wanted to quickly share a bit about who we are. We are the Tri-County Regional Energy Network, also known as 3C-REN. And 3C-REN is funded by ratepayer dollars that we all pay into our utility bills through the public goods charge. The benefit of being ratepayer funded is that there is no cost to those we serve. And as a regional energy network, we are able to return these ratepayer dollars back to our local economy, which has historically missed out on many of these funds that usually go to the utilities. You can go to the next slide. Thanks. 3C-REN currently offers 6 programs focused around 3 services. These include incentives, training, and technical assistance. The training series that we are watching today is part of our Building Performance Training Program. You can see additional trainings that we offer and learn more about our other services by visiting our website, 3c-ren.org. You can keep going. Thank you. And then a few of our achievements. Since 2019, 3C-REN has had over 4,000 individuals attend our trainings. We've answered 334 Title 24 and Cal Green questions, secured $155 million for investments in the Tri-Counties, and completed 1,374 energy-saving projects. And we are all very excited to continue growing in all of these areas in 2025. And with that, I will hand it over to Jennifer and Grant to start today's training.
Thank you. Welcome, everybody. I'm glad you could join us. Yes, as Chloe mentioned, this course is part of the AIA California Zero Net Carbon Design Learning Units. It's the second in a series of 5. So if you take all 5, you'll get all 5 of the units you need for California architecture licensure. And as part of that requirement, here's today's learning objectives. We don't really need to go through them because you will get a copy of the slides later. And we will get going with today's agenda. We're going to do a quick review of California's clean energy goals, and then we're going to jump into heat pumps for space conditioning, space heating and cooling. We're going to talk a little bit about heat pumps for the consumer market. So really, we're going to go in deeper for heat pumps that are typically used for single family and small commercial to give you an idea of what affects costs and pricing. And then you can kind of extrapolate that into the larger projects you may be working on. And then some tips for managing kind of client expectations around this equipment. And as a reminder, I'm Jennifer Rennick with Inbalance Green Consulting and 3C-REN. I'm a licensed architect and a certified energy analyst. And Grant Murphy, who's also on the call, is going to jump in and add more information to slides. Anything I've forgotten, also be able to answer all your questions in the chat. And Grant is also a certified energy analyst and a code coach for 3C Rend. So California in general is moving towards building electrification and has clean energy goals for the entire state. So one example is California's Air Resources Board campus, which is an example of zero net energy, on-site photovoltaics, battery, and the facility itself actually does the emissions testing on vehicles and cars. So California has a kind of three sort of prong approach for carbon reduction by creating buildings that are increasingly being decarbonized, both in energy use and in looking at embodied carbon. Although today we're focusing, or this whole series is really focusing on our energy use as part of the decarbonization effort, and looking at the industrial sector to make sure that all of California's industries are powered by clean electricity, clean fuels such as green hydrogen, and looking at our transportation, including public and private, privately owned vehicles and fleets, and working towards getting all of those to be electric or hybrid, or hydrogen zero emissions transportation. So with our buildings, we basically have kind of the approach we can use on new construction, which is relatively easy in that we can design our new buildings to be all electric. And so that means we can use heat pump technology for our heating and cooling, heat pump technology for our water heating in many instances. There might be some applications where that's not viable, but the idea is to move towards our buildings being all electric as much as possible. The California Energy Code requires that we have solar photovoltaic systems and batteries as part of certain building occupancy types to help with our distributed energy production. And then for existing buildings, it's more of an incremental opportunities approach, where as old equipment needs replacing, we can replace it with newer, more energy efficient heat pump technology, equipment that has lower global warming potential refrigerants. That goes as well for appliance replacements that might include your dryers, your cooking, your hot water heating, and then of course the on-site solar and batteries and envelope improvements. And then for our existing communities, it's the infrastructure approach, where we're going to look at decarbonizing the grid in general by adding more renewable energy, more battery storage, and reducing the need for gas-fired peaker plants. So that was kind of covered last time, but this is our sort of three-bucket approach to what California is doing and how it applies to our buildings. So speaking of the global warming refrigerants in our heat pump equipment, this is kind of a big deal in that under the AIM Act, the EPA set a limit of 700 GWP, or global warming potential, for chillers, air conditioners, and heat pumps manufactured after January 2025, which is taking place now. And the American Innovation Manufacturing, or the AIM Act, called for the phase out of those refrigerants with high global warming potential. Right now, most of our heat pump equipment uses R410A refrigerant. And just kind of put that in perspective, R410A refrigerant has a global warming potential of 2088. We want now all our equipment to have a global warming potential of 700 or less. So what we're going to start seeing more and more is that a number of manufacturers are adopting a refrigerant called R454B or 454B. It's got a global warming potential of 466. It's comprised of a low global warming refrigerant and R32 refrigerant. R32 itself can be used by itself. So some manufacturers are going that route, and that has a global warming potential of 675. Now, the thing with these refrigerants is that R32 is considered to be slightly flammable, has a designation of an A2L. So so you might hear that come up as why some people are resistant to using the low global warming refrigerants. But I'm sure Grant can chime in a little bit more. When it's slightly flammable, but it's relative. Like, it's not more flammable than the natural gas running through your house right now, for example. And then I'm going to let Grant say something about that in a second. And then the other refrigerant you're going to start to hear more and more about is R744 or CO2. So they're using CO2, carbon dioxide, as a refrigerant, and it's got a global warming potential of 1. The equipment requires a little bit more heavy duty piping because it has a higher pressure that it needs to operate under, but that's going to be showing up more and more. Okay, Grant, do you want to?
Is the next slide the one showing the thresholds of flammability?
No,
Oh,
I
okay.
didn't put that one in.
There's the rating system on what determines how flammable these refrigerants are. There's a threshold that is what a lot of people refer to when they recognize these new refrigerants as being highly flammable or very flammable. And we usually have a great graphic in here that shows that some of the new ones are, 1 to 5 more flammable using a metric of combustion on that scale that just tips it into that next tier. And then when you look at natural gases, propane, natural gas, it's significantly higher in the further tier. So the conversation we like to have is, instead of fearing the flammability of these new refrigerants, looking at that scale, and that they're not actually significantly more flammable. It's just how the testing and governing bodies rate that level of flammability, from being like none to slightly. So that's kind of a misconception that we're hearing a lot right now with these new refrigerants.
Yeah, that's great. Thanks, Grant, for clarifying. So we're just trying to give you guys some information to sort of head you off at the pass, so that you're informed and you don't go down that rabbit hole of like, oh my God, this stuff's flammable, we can't possibly be doing this, where it's not really the case.
Yeah.
So, okay. So now, okay, put a pin in that. And now we're going to be looking at kind of where heat pumps and where we're seeing more and more of them being used, and in our projects. And a lot of these pictures, because they're all prior to January 2025, most of this equipment is using R410A, but everything I'm showing you is going to be switching over to other refrigerants, and you'll start to see those in the market this year. Okay, big picture for heat pumps for space conditioning. There's really 2 buckets of heat pumps. There's air source, which means the outdoor equipment for the heat pump. Okay, back up again, heat pumps. You've got outdoor equipment, like think of an air conditioner. You've got your outdoor unit on the air conditioner, and you have your indoor fan coil and air handler on the inside. Same kind of thing, only the heat pumps are going to provide both cooling, air conditioning, and heating. You have an outdoor unit that could be ground mounted, wall mounted, but it's above ground and it's called air source. And then we've got the other bucket of ground source, geothermal, water source. And typically these systems are comprised of vertical drilled holes with U-shaped pipes. They're about 4 inches diameter. They might go down 100 feet, 400 feet deep. They're grouted in place, and they're using either the cool or the heat of the earth or water to transfer that energy into the refrigerant, which goes to the heat pump and then into the building to provide space conditioning. In our Tri-Counties region, we mostly have air source, and so that's what we're going to focus on today. Although I do know of projects up in Paso Robles area in North County, San Luis Obispo, where we do have some hot springs and geothermal ground source heat pumps are being used here and there. But today we're going to focus on the air source types. We can use them for just about every project type. We're going to see them a lot on residential, small commercial, and non-res, and also our multifamily and hospitality. And these pictures here are showing you examples of wall-mounted, roof-mounted. They can also be ground-mounted, but typically you're going to have one outdoor unit that goes to one indoor unit. And so in the case of the picture on the left for the multifamily hospitality image, really what this is a picture of is looking at a parapeted roof area, and you pass through the gate, and then you will see a line of these outdoor heat pumps all stacked up, and each one of these goes to an individual apartment. And then in the center picture, this gives you an example that these outdoor units can be mounted in covered parking areas, in garages where the air is tempered, or they can function outdoors. And then for the residential multifamily, you would have an example of one of those would be available for each of the duplexes, or it could be an ADU or single family home that is multi-zone. We can also use the heat pumps for the large scale and use them in commercial applications or hospitality or high-rise applications. And these are often referred to, when they're this size, as variable refrigerant flow or VRF systems. They can have indoor units that are ducted, like a regular ducted system that you would think of in many of the buildings we use and live in, or ductless systems. And we're going to show some pictures of what the ductless systems would look like. They are variable capacity systems, which means that via branch box and heat exchanger, they're able to simultaneously heat and cool spaces in a building. So you could have some zones calling for heat while other zones of your building are calling for cooling, and the same equipment up on the roof or ground mounted could provide the heating and cooling for the whole building. This is an example of what this looks like on a building that Grant was commissioning for a multifamily senior living project up in San Jose. And so it has a ducted VRF, or variable refrigerant flow. The system is Daikin. They call theirs VRV, by the way, just but it's the same idea. And there is an indoor fan coil unit. This is sometimes called a pancake unit, and this air handler on purpose is designed to be anywhere from 9 to 12, 14 inches tall, but it could be 30 inches to 51 inches or so wide, and then it's got a corresponding depth. And so it's ducted return and supply. And in this case, the return is in the hallway of this apartment, and then the ducts go into the bedrooms and the rest of the apartment for this. And each of these fan coil units are connected to the outdoor heat pumps. The system is robust in that the maintenance staff is able to take a look through their electronic, digital control system and monitor every one of those fan coil units for each of these dwellings for the senior living situation. Grant, you want to add anything on this?
No, not yet. If you're gonna touch on like
Yeah,
when these are
I know what
applicable,
Grant's going
type
to
of
say, so,
project, size of
right?
project.
Yeah, so, okay, so for example, this is what system. So for this project, it has 103 dwelling units in 57,000 square feet. And there's like 12 of these outdoor VRF heat pump units. Okay, so this was one way to do it. And the picture that I showed previously, the photo that showed a lot of PVs, heat pumps in the background, that was the same roof. So it left plenty of room for a photovoltaic system for this project. There's another project we're working on in LA to give you an example of the other way you could do it, which was similar to, to this picture here with these individual units. They chose to do that, and they have the building is about 10 times bigger, so just over 500,000 square feet, but they have 593 apartments, and each one of those has its own heat pump, and there's about 9 different models to fit the different varying capacities. So these are 2 different solutions that have very different sort of architectural implications for how you design with this. So the reason I'm pointing it out to this group of architects on the call is that you can use both these kinds of systems for large buildings and small buildings, but you'll need to, I think, have a handle on the implications for the amount of space or maintenance, and then work with your construction design team, mechanical engineer, on the cost implications. And this kind of gives you an example of what we're seeing a lot in our Tri-County regional area, where this is a single-story building. It's for a winery up in Paso Robles, and they had a variety of systems. And so basically there's different needs for the different type of equipment. So this multi-zone VRF is Samsung. They went with Samsung brand. This outdoor unit, the back of it, it shows you the fan coils, and you got a left side and a sort of a front view. That unit stands approximately 67 inches tall. This one's about 51 inches wide and about 30 inches deep. Gives you an idea of the size of it. Needs clearance. This could be roof mounted, but in this case, with the way the building looked, it made a lot more sense to have it ground mounted. And it made a lot of sense for them to use this multi-zone VRF in a wine laboratory with private offices and group offices. But same building, they had also a need for just one big meeting sort of flex space. So they put it on its own system. That's a 5-ton double stacked unit there on the left, and it's ducted to this. And then for their workrooms, it made sense to just have simple, inexpensive, wall-mounted, ductless unit with its own outdoor compressor. So we're really seeing just a blend of the equipment pieces depending on the needs, even in the same building. And then the last type of heat pump we're seeing when folks are very conscious budget is a package terminal. They were called package terminal air conditioners, but it's really package terminal heat pumps now to, so PTHP for the heat pump to kind of differentiate that it is providing heating and cooling. But a lot of times when you look it up on the manufacturer's website, you'll just still find it under PTAC, PTAC. Some brands are offering a small duct kit extension so that you can heat the main space for the small apartment, such as this small senior living multifamily. And then a small duct can run into, say, the bedroom. And this unit itself is about $1,000, so it's in the same price range as the lesser expensive just single head wall mounted unit. But these are easy to install, and these now increasingly are being offered as an R32 refrigerant option. So lower global warming potential, small amount of refrigerant because the unit is so compact and easy installation.
Yeah, Jennifer, these we had a question about those. What brand those are? Usually I see Amana, AMANA, as the primary distributor of those. They do come with some issues. Obviously they're very budget systems. Air sealing around them is always difficult when we see it in the field because you're cutting through the wall and installing the unit. Their efficiency ratings can be really low. So that can be a problem depending on the actual make and model that gets selected. And then the fans, because ventilation is always part of these the discussion when we're designing these systems. The fan wattage, the fan speed, if they're pulling outside air, if they're not, if they have that capability. It's a rabbit hole of finding the correct make and model. And often what I found on projects that are pursuing these is that they end up finding a premium version of those PTHPs, that the cost consideration isn't as good as when you buy the really cheap, poor unit. So that's something to consider before jumping down that road.
All right. And there are a couple of high-end brands out of Italy and Europe that addresses some of the issues that Grant was talking about, but then you're back into, is it worth getting those compared to maybe the ceiling, recessed ceiling, ductless units and pulling in a little bit of outside air. But I wanted to show you kind of distribution options that are available with the new heat pump technologies that we have available to us.
Andrew had a case where they were looking at a European manufacturer and they didn't have the certifications to be sold in California. Personally, I don't recommend using these ever, really. They usually cause more problems in the design process than they're worth when trying to find, proper units. But they are available and we're still seeing them being used. So they are something to be aware of.
Yeah, and that was a real project in San Luis Obispo County, but it was closer to Santa Barbara, and the climate is mild. So that's the other thing. Yeah. When we're talking about the real mild climates, it's not as big of a deal. But if you're in North County, San Luis Obispo, or say you're in climate zone 9 or 16 or some of those in Ventura County, I would go with these other systems that where the air sealing is not an issue and the efficiencies are improved. So this kind of gives you a visual of sort of the distribution systems that are available, large scale, small commercial, residential. But what I'm showing you a picture here is typically what we're seeing for our tri-county region, Santa Barbara, San Luis Obispo, Ventura counties. The buildings are, well, shoot, even that one that was 50,000 square feet, high-rise residential that we discussed, they still opted for one-to-one outdoor unit with ducted indoor units. So they can have a variety of use is what we're seeing. I'm going to show you a couple slides here, kind of just go over a little bit about sort of the parts and pieces of these. And this is basically the same parts and pieces, only on a much larger scale for the VRF. But if you're looking at this as an architect, you can have a big impact on ADUs, residential, small commercial projects. It's good to understand what we're looking at and what the parts and pieces are of this. So your kind of ductless mini split heat pump overview, you're going to have an indoor head. In this case, I'm showing a wall mounted unit, could be ceiling recessed, could be floor mounted. There's an outdoor unit, the compressor or condenser. And then you're going to have your line set or your refrigerant piping that connects the outdoor unit to the indoor unit. And this has to be insulated. And then along with that insulation, you're going to have a condensate line drain hose, because there is a fan coil inside the indoor unit and a blower. You're going to blow air across that coil that's been cooled down with the refrigerant when you're in air conditioning, air cooling mode. And there's going to be condensation on that system, just natural condensation like you get on a cold glass of water inside your house. That same amount of water is going to have to be taken out of that system, and hence the condensate drain line hose. So that's something to be aware of, especially for interior wall mounted applications. You have to think ahead a bit about where you're going to take the condensate. If the exterior wall, you could take the condensate to the outdoors, no problem. And then there's a communication or power line that connects the two, and then they have electrical connection. So typically they only need like a 20 to 40 amp breaker, and they do have these at 120 volt. Those units are more expensive, or more commonly like 230, 240 volt system. And then kind of what it looks like inside, there's some onboard electronics that I don't illustrate here, but this is just showing you the main kind of parts and pieces. That inside you do have a compressor. You've got a 4-way reversing valve, which allows it to heat and then switch so it can cool by changing the direction of the refrigerant flow. You have an outdoor coil, and then you have a special metering electronic expansion valve. And that's really what allows these units to have such high efficiency, because of the electronic controls on board that can meter out the refrigerant in micro amounts very quickly and adjust the amount of refrigerant, therefore increasing the efficiency. Now, when you talk to your clients and they're maybe not sure what a heat pump is, the best example you can give is a refrigerator, because everyone's got a refrigerator and their refrigerator is a heat pump. So you've got a compressor on your refrigerator, you've got your blower or your fan that you can feel that warm air blowing, out at the bottom of your refrigerator. So, and then you've got also an expansion valve metering device. And then you have your evaporator coil, which provides that cooling in, for the refrigerator or the freezer compartment. The distribution system, kind of repeat the types, but I want to give you just a little bit of a little more information on it, is that, and especially when you talk to your clients or just trying to understand the difference between the different ducted systems, like this type of ducted system looks like a traditional air handler, and that the shape of it is more what you would see for a furnace air handler or an air conditioner combination furnace air handler. You could do long duct runs, you could put it in soffits or chases, and so really the pathways are similar to forced air units. And you can locate these in your garage or an equipment room, or up in an attic for that matter. They can be laid horizontally up in an attic.
Yeah,
And then, oh, go
the
ahead.
air handler units, those are the ones I recommend versus these pancake units that you're seeing just now. They're both hidden, so you have registers like we're all used to. The difference is these pancake units, I don't recommend having any significant duct run. You can see in that photo, we can't see how far they went, but you know, 10 to 15 feet, depending on how many. It's really limiting. And once you try to do extended length duct distribution systems, these units, we've seen a lot of issues with them being able to deliver the airflow, um, making noise because of the static pressure. I really recommend, as soon as you're thinking a more central system or a longer run of duct, that you accommodate for that air handler unit rather than these pancake units.
You're right. And especially, okay, so like residential
Yeah.
applications, even though this is a commercial application, it's, you know, it's applicable small commercial and residential. So if you have the space for it, that this seems to be easier for the duct design. When you work with your mechanical engineer, they're going to do a duct design for you. They should be looking at the entire design, whether they're doing the concealed duct sort of pancake units or the other type. If you're working with a homeowner directly and they want a ducted system, then it behooves you as the designer to think about where are you going to locate these air handlers, because then you're going to be working with someone. If you're not working with a mechanical engineer, you're going to be working with someone like Grant, who could do or me, or someone else out there who could do the ACA calcs for you for the duct design. And these units don't like a lot of static pressure. So they're really designed for short, compact duct runs, which, if you've designed your whole project to have short, compact duct runs, you know, these can work well, but they need to be short, compact duct runs. So these worked great for like that small the multifamily project I showed you, because the whole apartment was relatively small and the system was centrally located. And I think each of those little ducts went out, oh gosh, like across the hallway. So 5 feet one direction, 6 feet in the other direction. It was small, but you could hear it. You could hear it in the return ventilation. Okay, they could be located in this case, attic, or what's going to end up having a drop ceiling here, or crawl space. They're really for compact, you know, space where you don't have very much room to do the larger air handlers. The ductless systems, there's wall mounted and there's ceiling recess, 2 types. I show here sort of the ceiling recess that is kind of wider and longer rectangle shape. They were designed to fit between joists. So they're typically 21 inches, 20 inches wide. So they would fit between a 24-inch on center ceiling or roof framing. and they have high efficiency. And it's possible to build them in a little bit and to use very, very open screening, not too close if you want to visually disguise them, but it's not recommended because you really don't want to impede their airflow. So this just gives you kind of the visualization. You can have an outdoor unit, and if it's the double stacked like 5-ton unit there on the left, you could have up to 8 indoor units, including ducted and ductless, and combine them depending on your needs. The market for these is quite extensive. There's a lot of brands to choose from, including do-it-yourself kits. There's approximately 218 brands right now being offered in North America alone. Although the top 10 manufacturers control approximately 85% of that American market. The other thing is that a lot of manufacturers have different branding names under the one manufacturer because they are targeting different pricing in different markets. They'll even have brand names in one state, could be the same piece of equipment, but given a different brand name in California, for example, because of brand recognition. They don't want to give up certain brand names in other states. And then there's a lot of the parent companies are buying, selling, and trading parts of their companies. So just this last July, Bosch agreed to acquire Johnson Controls and Hitachi's residential and light commercial system. And then this market's expected to grow by 40% by 2030. So when you look at that, it might seem a little overwhelming with the quantity of brands. If you go to Home Depot, I've just listed out the brands that are commonly available, or at least the last time I checked, these were the brands available. Home Depot, Lowe's, Ferguson Supply House, Costco online, you could get the Mr. Cool brand. And then through professional installers, you would get the Mitsubishi, Fujitsu, Daikin, Samsung. You can also get LG, but LG has a line that they also sell through Lowe's, for example. You could get like Carrier and Train as well, but those also have brands that you could get at these other supply houses. So, but through your professional installer, you could get everything really. So California, in our area, in our market, what we're seeing is that the kits are becoming more common, and the kits are being purchased by lay people, but also the kits are being purchased by professionals because it ensures that you've got this compatible indoor unit and outdoor unit. You've got your remote thermostats, the condensate line, the refrigerant line, that communication wire. It's all together. Some of the kits are even including tape and putty for patching holes, and surge protectors and electrical disconnect. But every one of these kits still has the disclaimer that this has to be installed by a qualified professional to ensure the function and safety. But mostly it's because a lot of these kits don't have pre-charged refrigerant lines, and so you are required to have a professional and hers come out and take a look at the refrigerant charging, make sure that went accordingly. For the wall-mounted units, the most kind of simple we're seeing, especially with ADUs and in remodel situations, retrofit, older homes being redone, you could get a wall-mounted unit. It comes, you look at the back, you pull off the line protection, you pull out the line set, Doesn't take very long to wall mount it, drill a hole where it tells you to drill the hole so you can stick that refrigerant line and the comm line and all that out and outside and run it to your outdoor unit. It's pretty straightforward. The parts that impact the pricing, or I mean the aspects that impact the pricing the most, is whether or not they're offering a promotion. That's kind of the first thing. So a lot of these units, especially the ones that have the 410A refrigerant right now, are being offered at a pretty good discount. And then once you get kind of beyond that, then the next sort of level that impacts costs would be the indoor sound rating. And so this can be, the more quiet, the more expensive it is. The higher efficiency usually is costing more. And then as the capacity goes up on the units, the cost goes up. And if they have a low ambient temperature or something called hyperheat, that often costs more. And then the 230, 240 volt units are less expensive than the 115, 120 volt units. And I'll show you an example of that. And then the refrigerant line itself, just maybe this is intuitive, but the longer the line lengths you need, so the further away the equipment, indoor units from outdoor units, that increases the price of the system. And then for like a clean install, this is where a couple of these items is something that, like architects, you might want to make sure you put on the drawings that you want an exterior line set cover. Otherwise, on the retrofits or remodels, you're going to see the comm line, all of it could be taped up. It might be zip tied together. It's not that pretty, not that attractive. I would make sure that you call out that you want an exterior line set cover, either made out of sheet metal or one that's made out of PVC or other composite material, comes in a few different colors. And then all of the piping should be insulated. And then as a reminder, you can either ground mount these or wall mount these, or even put them on racks to protect them on the ground, but keep them up off the ground. And then all of them require some kind of electrical work. They need a breaker box with a shutoff. The pricing on these well, let me back up a little bit. I'm going to run through like 3 different price range, give you an idea of what's out there. And then there's many brands under each of these. So for example, the Pioneer brand, it's made in the US. It's not expensive. It just comes in white. You can get it at Home Depot, Lowe's. You can also order it direct. It is Energy Star rated, but some of the things that kind of keep the price down is that it doesn't have a lot of bells and whistles. It has a 5-year standard warranty. You can pay more or have other options to extend the warranty. And this price range is going to be under $1,000 up to $1,600. And it does require a professional installation. The efficiency is pretty good on these units, and there is a range. So Pioneer has a range within this, and they also have kind of a range, in the different brands, whether it's 3-speed or 4-speed or variable fan speed. The sound rating, the quietest one is rated at 21.5 decibels, but it goes up to 42 decibels. So 42 is not that quiet, especially if it's in your bedroom. So that's where we're finding like the more expensive ones are much quieter. They do have options to have it work for very cold temperatures. And then because this is a lot of times sold in areas of the country that folks aren't doing right sizing by a professional, they do have a website that includes an interactive drop-down menu to help you pick the right size for your space. If you go kind of up in price a little bit, it's not necessarily better, it's just sort of the next notch up in cost are your do-it-yourself kits. So like Mr. Cool brand has a do-it-yourself kit. So now the price goes up from, $1,000 to, $1,200 to close to $1,700. Again, these are available at Home Depot, Lowe's, Costco. You can order it online, but you can technically install it yourself depending on your skill set. But you may need assistance for the electrical work. But they try to make the electrical work really easy on these. So this unit, for example, meets that 120 volt. So you don't have to bring in higher voltage for this unit. It's also Energy Star rated, but your color options are white, and the warranty is quite a bit less with just a 2-year on the parts and 1 year on the compressor. But the thinking is you can install it yourself. So overall, you would save money. And the way they do that is they have what's called their no-vac quick connector lines. And these refrigerant lines are pre-charged, and you can order the length of line. I think there's 3 line length options to choose from. And you can connect it up to your phone. There's 4-speed and variable speed types. But again, your options on color and style is limited. It comes in white. Go up from there, and then like it's the Mitsubishi and the other higher end products, quite a bit more expensive. So just a single head wall mounted unit could start at $1,600 and go up to $2,000 just for the one-on-one. So we're basically doubling the price, and that doesn't include the install. So for like the Mitsubishi or these others, it requires an installing contractor because you're going to buy the equipment through your installing contractor. But because of that, especially if you use like Mitsubishi Diamond Contractor, you can get an extended warranty for up to 12 years. Compare that to the 1 and 2 year warranty on the do-it-yourself kit. So, but the price goes up quite a bit because you're going to spend $2,000 on maybe the equipment, plus up to $3,500, $5,000 for the professional install, depending on the depending on how complicated the project is. If you have to run a lot of refrigerant line, or you're trying to put these on interior walls, for example, and then you have to include around $1,000 or more for your electrical hookup, because these are going to be that 230, 240 volt range. But you can also get these in sleeker looking models. Plus you could get them in black, gray, white, or slim styles are available. And they're really quiet, like 19 decibels inside with 5 speeds and much higher efficiency. And with these, they don't really have a tool. You can go in and kind of size it yourself, because you're supposed to work with a professional who would actually right size your whole system for you. Give you an idea of cost comparison, like the ceiling recess versus the wall mounted recess. Both are ductless systems. And really the biggest difference on these is the piece of equipment you're looking at doing promotional pricing. So if you were to take the Mr. Cool do-it-yourself example, doing ceiling recessed or wall mounted recess, no promotional pricing, nothing's on sale. They're actually about the same price for the equipment. But once you look at the promotional pricing and what sort of, you know, what a reseller is offering, then it's possible, like the example on the right, you could get the 2 wall mounted units for, you know, 25 to 50%, 30% less than the ceiling recess. So you just shop around is the bottom line. And then one thing you need to consider also on both of these is just how are you going to take care of that condensate drain path, whether it's in the ceiling or on the wall. That's kind of the key thing. And then real quick, give you a price comparison of the Mitsubishi, you know, within that brand. They've got their M series air handler and their P series air handler. And then you could also do like a 3-zone ductless wall mounted. So same capacity on the outdoor unit. 2 ways you could do the ducted system plus the wall mounted. And really the price difference is maybe $500 one way or another. The M series, this one Mitsubishi on the right was being offered from one source, a little less than even the wall mounted, but with the air handler, you'd have to include the installation of the ductwork and the labor. And however, if you have a client like I do right now that we're working with an architect, is like, the homeowners absolutely do not want the wall mounted look. They just don't want it. So we're talking to them about the M series, for example. And it'll cost a little bit more, but the homeowner's going to be much happier with the look.
Jennifer, I want to jump in. Charles had a question from a warranty and longevity perspective for commercial and civic projects. Do we have particular brands we recommend? Not necessarily. Kind of the point of what we just went through, that layout of like the budget systems to a more expensive premium system. Within each of those tiers, you know, I have multiple contractors, HVAC contractors, that each have their own preference for different reasons. You know, myself, Jennifer, I think we've enjoyed Mitsubishi, but a lot of it comes from their support team and the documentation and specs stuff they provide. They've done a great job on that. I've had guys that love Mitsubishi products. I've also had guys who say, I don't want to work with those. I prefer Samsung. And the reasons behind that can be, you know, just from a single component on install. Hey, I always see this breaks or something else, you know? So we don't really have one saying, hey, go buy this system. We've seen the best from them. I think the biggest takeaway from that warranty perspective, as you could see, is you're kind of going into tiers. If you are concerned about that warranty, buying one of those systems from a professional installer that you can get the extended warranties or the base longer warranties is the best route. Of course, that comes with a cost consideration.
Yes. Okay. And then just to wrap this up, some of the client expectations, then you're going to get a copy of these slides. And this last section, you can contact us, Code Coach questions. There's just some kind of one thing to remind the architects is you need to locate the outdoor unit away from things that create a lot of dust and debris. So like dryer vents. And they do require maintenance. A lot of people forget that you need to have someone come out and check up on the equipment. Not that it breaks, it's that if you want it to function as best as possible, somebody should come out and maybe clean the coils or make sure the filters are changed. And this is like the homeowner could do it, or in a multifamily project, someone needs to go around and do that, whether it's a ducted system or ductless. There are filters. They do collect dust and dirt to keep the interior coils and blower clean. So you need maintenance. You should be hiring a professional to do the ACA or ASHRAE load analysis. You might be working with a mechanical engineer or someone else to do your ACA calcs. So that's duct sizing and right sizing for the ductless systems, both. And then really quick, ADUs, especially, we're seeing this to get a compliance credit on your Title 24. There is a variable capacity heat pump credit, but it requires that the heat pump be installed within the conditioned envelope, and that could be done both with a recessed system, but architects, you would need to detail it so that the recessed indoor unit is within the conditioned envelope and air sealed. And then these are HERS measures. And all of these systems, whether it's the professional non-res system or your residential system, they're all supposed to be installed by a licensed contractor who can make sure that the refrigerant is handled properly and it's charged properly. And then lastly, especially on the residential projects, especially if you're taking HERS credit, that VCHP or variable heat capacity credit, we recommend you put that on the front of your plans, on your cover sheet, to alert the builder that that credit is being taken, because it dominoes into other aspects of the construction. And then last but not least, as a kind of a reminder plug, any questions on this stuff, and we're sure there's going to be more, please reach out to us on the Code Coach, and we're available to help you with your individual project and answer these questions. And with that, I'm going to hand it back over to Chloe, and then depending on Chloe's timing, Grant and I can stay on the line for a few minutes to answer lingering questions, but otherwise we're going to let you go because we are just a couple minutes over 1 o'clock.
We had a question already. Let me find it here. Scott asked if there's limitations for height that the wall mount units are mounted at, like in a vaulted ceiling space. To my
Not
knowledge,
really.
no, not really. It's just the bracket install, the actual footprint of the unit, the dimensions of the unit limit you. You'd have to consider, the refrigerant line length, condensation line length, but those are all pretty substantial. So I've never seen one where that's a limiter in residential construction.
There is Grant, there is so by the brand, there's going to be a height between the outdoor unit, indoor unit, refrigerant line height limitation because of the pump built into the system, getting it up to that height. But we haven't seen that be exceeded in most residential construction.
And that's an item too that I mentioned in another question I answered, where I'm primarily working with those professional line systems. And so they're charging the refrigerant on site. They're not pre-charged kit packages. So if you do use one of those pre-charged kit packages, those limitations are going to be more significant. You're not going to be able to, run it as high as if you were doing one of the other systems, the more expensive systems. But I haven't run into that issue. There is an effectiveness of the unit, just based on throw capacity, what's in front of the system, how that air is falling into the space, that kind of stuff. A little bit into the weeds in the design and effectiveness of that comfort, condition. But generally, no, there aren't limitations to height. Let's see.
All right, thanks so much, guys. And then quickly, I know people are starting to drop off the call. Just a reminder that if you join today's call, either by calling in or you use someone else's registration link to access the Zoom and you did not register yourself, just to make sure you send me an email with your contact information so I can make sure to get you the AIA and ZNCD certificates. And also, if you could distribute that information to anyone you know who may have called in or joined using your registration link, if they've already hopped off the call, that would be terrific. We will be sending out the slides and recordings and a brief survey in the next few days. If you can take that survey, it really helps us out. We really like to get feedback on these trainings and how we can improve them. And a reminder that we do have 3 more courses in this series coming up in the next month. So if you haven't registered for those, you can go to our website and register. We also have a course, Introduction to the Energy Code, coming up 1 week from today. All right. And then I think I have time for a few more questions. If anyone has any additional questions, I'm happy to stay on with Jennifer and Grant for as long as they have available.
Yeah,
Okay,
we can wait
great.
another moment. I just always want to plug the Code Coach. There's a web form and a phone number you can call. Anything Part 6 energy code, anything Part 11 green code, you send that in, hits my inbox. Jennifer or I will get back to you and we can help you with just about any questions, discussion, review. We can't do your compliance documentation and we cannot do plan review, but it's free and available for private, public sector, anyone. Share us around and utilize the program.
Yes, and then I just noticed on the chat, Scott Clark, he was mentioning heating mode. If you're high up in a vaulted ceiling situation, maybe not that effective, but with all these systems, like wall mounted or even the ceiling registered, I mean, they've got the fins at the bottom of the unit, so you can use the remote control and angle that air so it blows down more or blows across the space and lock it that way, or you can have it in a mode where it swings naturally, just kind of everywhere. And then the other thing is, with any vaulted spaces in any project, part of the holistic design is to really think about how you move the heat throughout the space. So with a lot of the like one of the builders that we worked with a lot, and he's actually co-taught our classes, he sets up his system so that it'll pull that air from that space down in through the rest of the house through small fan systems, and we'll talk about that in session 4 when we talk about how to bring in
Ventilation.
fresh air and ventilation and move the air through those systems.
Oh, yeah, John brought it up earlier. Sorry, John. John had a comment about air to water systems. And I think we usually have a couple slides where we talk about, we've reduced this a little for the webinar version. The air to water heat pump systems. Very cool. The combi systems, providing hot water and your hot air, sometimes heating and cooling depending on the system type. It can be really efficient, really effective, space effective. They're not a new technology, but they're not business as usual. They're not typical, especially in our area. So the only times I'm really seeing it is when a client comes to us with knowledge of it, seeking that type of system out, and then finding, designers and installers to work with them. When it's brought up in comparison to these air source heat pumps, these are just simpler and everyone's familiar with them. There's a lot of advantages that people are talking about with the refrigerant. When it goes back to all the refrigerant in those air to water systems is located in the unit rather than being run in a line to the indoor fan coil. So some people are, more concerned about that, and that's a major benefit in the quantity of refrigerant a system's using and where it's located. And yeah, they
And
can
we're
be
gonna
used for domestic hot water too. So there's cool systems that people are putting together that are really efficient and really effective.
And we're going to briefly touch on that next Thursday when we do number 3, because I took that equipment and lumped it in with the session on hot water heating.
Yeah. Yeah, we have one example, and there's a couple in St. Louis, but one that we're really familiar with that use like a hydronic furnace fan coil. So it's a split system heat pump water heater that is also providing the hot water to the fan coil. So the home is heated just off that water heater. The home doesn't have cooling, however, from that system design, which was what the client wanted in that case. So they're out there and they're being installed, and we'll talk more about it in the next one.
I'm looking at the chat. I see we still have 23 folks on the call.
Yeah. Feel
If
free to unmute, ask questions, anything.
right, and I can stop sharing, and we can, if there's folks on the call that have any other questions, or there's just a few of us now, if you want to unmute, or
We can go
if
back to
it's
work.
radio silence, we'll just say thank you, everybody.
Thanks so much for the presentation today. I think that might be the end of our questions. So I might go ahead and end the meeting. If you guys have any questions, I know Grant plugged Code Coach, that's also available. And we do have 3 more trainings in this series. So I hope you guys join us next week for hot water. And with that, yeah, I'll let everyone get back to their days. Thanks so much for joining. Bye.
Thanks,
Thanks,
everyone.
everyone.